Hello. So we're looking at moments at the moment, and we've seen that it's not the size of the force that makes the difference, it's not the size of the distance to the pivot that makes the difference, but it's the combination of the two. Because a moment is the size of the force multiplied by the distance to the pivot. So I've got this great piece of equipment to demonstrate this. It's like a seesaw, which is like a number 1 type of lever. And it's got some numbers all the way along to show us the distance from the pivot, which is the point where it will swivel, and then it's been set so that it's perfectly balanced at the moment. Now, if I place a 10 gram mass, which has a weight of about 0.1 newtons, onto the middle of one side, we'll get a moment. And the moment will cause the seesaw to turn. And at the moment, it's set to turn anti-clockwise. It's turning that way, the opposite direction to a clock. Now, it's easy to balance it by placing another weight in exactly the same position on the other side. It takes a moment or two to find its balance, but there we have it. It's perfectly balanced. But that would be the easy solution. Now, if I place 2 weights onto this middle position, this 5th position on the anti-clockwise side, I can balance it with just 1 weight on the clockwise side if I set it twice as far from the pivot. So there we have it. In other words, a really easy maths lesson. 5 times 2 is the same as 10 times 1. Obviously these can get more complicated, but as long as you bear in mind that it's the force multiplied by the distance, you can't get it wrong. So for example, if I put 1 here at 4 and another 2 here at 3, so that's 4 times 1 and 3 times 2 is the same as 10 times 1. Remember, always add up the individual moments. So I can't do 3 times 3.5, for example. It wouldn't work. I have to do 1 times 4 plus 3 times 2 is equal to 10. Let's try another one. I'll put 1 on the 10 and 2 on the 5. And then another 2 on the 2. So 1 times 10 plus 2 times 5 makes 20, plus 2 times 2 makes 24. I should be able to balance that with 3 on the 8. 3 times 8, 24. Or alternatively, I can also balance it with 4 on the 6. And that's how it works. Now this can be really useful. It's one of the simple machines that we often take for granted. But for example, if we need to lift a very heavy weight, so I am going to put 10 weights onto the first position, very close to the pivot. I can in fact balance that with just 1 weight, provided it is 10 times further away. And that's how levers can be so very useful to us in our everyday lives. It's also the reason why the door handle is never placed close to the hinges, but as far away from them as possible.